Hi guys, welcome to Piece of Code and welcome to this video. And this video is going to be a concept based video where we are going to learn about Amazon SQS and SNS, a lot of practical examples, how does it integrate with other AWS services, and also we're going to cover the theory concepts which is required for your exam, like your developer associate exam or your solutions architect exam or cloud practitioner exam. It's common for a lot of exams, and I've noticed that a lot of questions actually come from these topics, not just related to SQS and SNS, but how does it integrate with the other services. That's how they test you actually, because you're going to learn SQS and SNS they kind of act like a bridge between a lot of applications, like in simple words, like a data transfer mechanism. It's not actually that, it's a lot more than that, but in simple words, just to make things simpler from the beginning, let's start this topic. Okay, so let's talk about Amazon SQS Queue. Right now, just going to the definition of SQS, guys. SQS is a fully managed message queuing service offered by AWS. It enables decoupling and scaling of microservices, distributed systems, and serverless applications. Alright, so let's take an example, right? What is the problem and why do we need a queue? First of all, let's understand that, and let us then understand this diagram that is in front of you. For example, you have two microservices. Very simple example, you have order microservice and another one is the payment microservice, right? Now what happens whenever a user, right, places an order? So this order microservice will call this payment microservice, right? And then the payment microservice will process the payment. Whatever order the user has placed, the payment microservice will process the order, the payment, for example. Now what may happen in this case? What kind of problems may arise in this particular scenario? Now there can be a case where there are multiple users, right? A lot of users, because your application is gaining a lot of volume and there are a lot of users now. They are placing multiple orders. I think thousands or 10,000s of orders they are placing at a single time. But due to some reason, your payment microservice is not able to process those orders in real time, or in the sequence in which it is received, right? Maybe because it is down, or it has a lot of load or a heavy traffic. Due to some reason, it's not able to process the orders, and due to that reason, these payments are getting failed, and there is some things happening, like the order is not getting processed and the users are facing a lot of issues, right? Because the payment service is down. It's not the problem with the orders microservice, but it is the problem with the payments microservice, right? I hope that is making sense. Now, what can be a possible solution for this? One solution maybe is that you create more instances of payment microservice. So if this payment microservice is down, then the order may flow to this microservice or that microservice. That is fine. In the cases of autoscaling, this works perfectly fine, right? But still, there can be problems like in which order the payments needs to be processed, right? The payment microservice needs some time before processing another order. Just by this architecture, you will be able to easily handle the load, but you will not be able to efficiently process the load. There is a difference, right? So along with autoscaling of your, for example, your payment microservice, you need some kind of queue in between, so that queue will act like a buffer, right? And it will sequence your orders, and it will know that, okay, this microservice is free, I'm going to just give the order to that payments microservice, or otherwise this microservice is free, I'm going to push the message to that particular microservice, right? So that is an example where a queue actually comes in handy, and it actually creates a lot of difference along with your autoscaling feature, horizontal autoscaling, right? So yeah, let's I hope you understood the general scenario and why do you need it. Now let us understand this diagram that is front of you, guys. Here you can see certain things over in this picture. One is known as the producer, right? Another one is the queue, and third one is the consumer. That's how a particular queue works, right? Now in the previous example guys, you can easily guess who is the producer and who is the consumer. In this case, the order microservice is the producer and the payment microservice is the consumer, right? So the producer is the person, not the person, the service which actually generates the particular message, and the consumer is the application which consumes the message, in this case the payments microservice. And the queue is the the buffer that I am talking about, which actually holds all of your messages, so that it provides you with a lot of different features. For example, one is it will act as a buffer, it will handle the peak loads whenever there is a lot of loads and your consumer is not able to handle, and it will also sequence your messages. It has a lot of other features as related to SQS itself. We're going to discuss that in detail no matter what. Yeah, so that's how it works guys. So we have a producer, we have a consumer, and then there is a queue, and the queue is responsible to act as a buffer between your producer and consumer, so that if your consumer is not able to process or there is some issue with the consumer, the queue will be able to hold the messages until your consumer is ready, or a lot of other features as well, right? I hope that is making sense guys. So let us go through some theory points now. We understood what is a SQS queue, like a simple queue service, Amazon SQS. Now there are certain types of queue that you need to keep in mind. So the first type of queue that you wanna understand is the standard queue, which is like the basic functionality of an SQS queue. So you have a producer and you have a consumer, right? And then there is a queue in between, that is a SQS queue, and that's standard. So it offers best effort ordering, at least once delivery, and nearly unlimited throughput. Standard queues provide high throughput and are suitable for most applications. Now standard queues, you need to keep some key points in your mind guys whenever you talk about standard queues. First is that at least once delivery. Now in terms of English, what does at least once means? At least once means more than once. It can be more than once or more than once. So your message duplication can occur. I mean, if the producer sends a message and there is already a message of the same kind there, the same message can go again inside the SQS queue, and the consumer may reprocess the same message. Now you may argue that I will keep track of the messages in my consumer, and I will put a ID on the consumer side, which will differentiate between the already processed messages. Yes, that is true. That is the logic that you will apply from your side, and that is also fine. But just talking about standard queues, it will provide you the basic functionality of the queue where message duplication may happen, and it will allow you at least once delivery, right? So you need to be sure of the fact that your message will be delivered, but how many times it will get delivered, that is the question. Okay, that is the thing. Second one is the FIFO queue, or the first in and first out queue, right? So it guarantees the order in which the messages are sent and received and ensures exactly once processing. Now the same problem, if you have a problem with the message duplication, you don't want the same message to be duplicated again or sent again, you will probably go with the FIFO queue. It is ideal for applications that require strict ordering and deduplication of messages. Now here is an example of FIFO queue. If you see, so we have two message groups, message group B and message group A. Now if you see, if you talk about a standard queue, it will not keep track of your messages, it will not ID your messages, or it will not care about how many messages of the same kind is there. But if you see a FIFO queue over here, if you see this diagram, you see if B3 came first, that is the first order, so B3 order is maintained, then B2 and then B1, and then for the second message group A, A3, A2, A1. So it is maintaining the sequence in which your messages are being consumed, or produced. And if you see, the order in which the consumer 1 receives the messages is A3, A2, A1. That is how it was ordered in the queue, and then B3, B2, B1. So direction of travel, last in and first in. So basically that's how it works. right? So B3, B2, B1 came first, and then A3, A2, A1. So it got first in A3, A2, A1 and B3, B2, B1. I hope that is making sense. It's a pretty simple logic over here, right? And that's how a FIFO queue works. And generally this is a very basic question and a very common question which comes from SQS. What is the difference between FIFO queue and a standard queue? In the exam they will not obviously directly ask you the difference, but they'll try to twist you in some question where you have to choose between a FIFO queue and a standard queue in SQS, right? I hope that is making sense, guys. So let's move forward, and instead of going only theory, let's do a small practical session on SQS so that this session is not that much boring. And yeah, and then let's continue with our theory. Okay guys, let's see a practical about SQS. So I have logged in into my AWS console. You can also try that with me if you want. And without wasting any time, we'll just search for SQS over here, and I can easily find simple queue service over here. So let's click on that. So this is the SQS service, and you can see there are some examples over here. If you wanna just mess around over here, SQS provides high throughput system messaging. You can use queues to decouple heavyweight processes and buffer and batch work. SQS stores messages until microservices and serverless applications process them. Simple definitions, guys, and here are some use cases and some related services. Okay, so we're going to click on this create queue method, this button, guys, and here are two options that we just learned. One is the standard queue, which says at least once delivery, and here is the first in first out delivery and exactly once processing, and this is the FIFO queue, guys. I'm just going to name this queue as an example queue, example_queue, and just let's not worry about all these configurations for this time, guys. We're going to learn about all these things in our theory. Let's leave it as of now, and let's move on to the encryption section. We're going to just obviously enable the encryption of our messages, and we're going to use the default encryption which SQS out of the box provides, which is SQS key SSE SQS. If you remember my S3 lecture, guys, there is SSE S3 encryption, which is also out of the box for S3 service. Now similarly, there is SSE SQS, which is basically out of the box for SQS, but you can also, if you have a key or something which you have created using KMS, you can use the same thing, a master key for that particular thing, if you want to have a little bit more control over this encryption, but I'm going to stick with the default encryption. Now the access policy is the basic access policy, basically who will be able to access the queue. We're going to keep it as the queue owner. So the queue owner is for now is no one but me, right? I'm the user who is creating the queue. So whatever things I will do with the queue, I will be the one who will be doing it. Any resource that I create, I will create. So I am the owner of the queue, and I will be the one who will be able to send and receive from the queue the messages, to be exact. Now you can actually mention some other accounts or IAM users or roles which you want to give permission to access this queue. You can specify them here. This is the who can send messages to the queue and who can receive messages from the queue. The same thing. You have to give the ARN or the role or the user, whatever you want to give the access. I hope that is making sense, guys. This is just for the access policy. You can also go with the advanced section and you can edit this access policy yourself, like what action you want to give. You want to SQS push messages or queue messages or something like that. Actually there is one tool which is known as policy generator. You can use that. Actually it is pretty simple. I don't exactly remember the the things like what are the actions and all. You can use this policy generator, and this is the queue policy. Allow principal is if you want to give everyone the access, you just keep it star over here, and if you see in the actions, you can say create message, delete queue, list queues or whatever, or tag queue, or for example create queue, delete queue, whatever you want to give, you can give, right? Purge queue, receive message, just an example this is, right? And the ARN basically to whom you want to give the actions, right? Sorry, the ARN is the queue ARN basically, right? This is the ARN, the resource. You want to give the, assign the things to the queue, right? Then you can just click on generate the policy, add statement, it will generate the policy, right? That should be fine. Pretty simple, guys. So yeah, we're gonna stick with the basic thing for now. Don't wanna make things complicated. And dead letter queue is also another thing that we are going to discuss in the theory, so let's ignore it for now, and let's stick it to the basic things and let us create the queue. All right, so now our queue is ready, and now here there is an option to subscribe to SNS topic, which is interesting. Why is there a SNS topic subscription over here? We're going to learn about this pattern later on in this lecture only, so let's ignore it for now. For now, we're just going to send and receive message, that's it. So let's click on send and receive messages, and let's send a message. For example, I'm going to say test message, and we're going to send this message. Now, an interesting thing about SQS queue is that it will not push the message to your consumer. I mean, if you are going to send a message from point A to point B and you have a SQS queue in between, right? Point A will send the message to the queue, and the message will stay in the queue until point B polls the message from the queue. Polls, P-O-L-L, poll. So there is a concept of polling in SQS. So whenever the consumer needs a new message, it will poll or ask the queue, you know what, queue, hi queue, can you please give me a message so that I can process it? And then the the queue will just give the message to the particular consumer, and the consumer will process it. So how does it happen? When you are receiving the message, you can see that messages available is 1, but still the message is not processed or not visible. Now for now, the SQS queue is the consumer and the producer. So let's see the example over here only. Later on, you can have a consumer and a a producer microservice, and you can play around. So here in the receive messages section, there is no messages, but still there is available messages are 1. So now what I'm going to do is I'm going to click on poll for messages, and if you see, that's it. We got the message. We can click on this message, and we can see that the body is text message, the attributes and some details are also there, like what is the sender account ID and whatever. So this thing you need to keep in mind, that SQS doesn't push the messages, but it polls the message. Now for pushing the message, there is another topic known as SNS, simple notification service, that I just talked about. We're going to do that later on in this lecture. But remember that SQS polls the message. The consumer should poll the message from the queue in the case of SQS, right? I hope that is making sense, guys. All right, let's move on to the next section, guys. Okay, guys, now let us talk about this message retention period and what does it mean. So you would have seen some these parameters while we were creating our SQS queue. There was some parameters like the visibility timeout, which you can configure, the message retention period, some other things were there, right? Now let us talk about the message retention period, guys. So as the name suggests, it just shows you like how much time will the SQS queue retain the message, right? And if you see, SQS retains the message in the queue for a configurable period, the least being 1 minute and the maximum being 14 days. It just means that if a message is being sent into the SQS queue, the maximum time it can be retained in the queue is 14 days. And if a message is not processed within this period, it becomes available for processing by another consumer, right? It's simple as that, guys, very simple. And you need to remember this thing, that's it. 1 minute to 14 days is the interval of time for which a message can be retained in the SQS queue. Okay, now talking about the deletion of messages, guys, you can directly delete the message from the queue, and you can do that using the delete message API. Now the API will not call it directly, you will either call it from the UI, like by clicking on a button like delete message, or if you have a AWS CLI, you can call this API with the ARN of the SQS queue and you can delete the message, or from the code also you can call this message API and you can delete the message, right? It is possible. Okay, all right. Now let us talk about a visibility timeout, guys. Now what does visibility timeout means? When a consumer receives a message from the queue, SQS hides it from other consumers for a specific period called the visibility timeout. If the message is not deleted or processed within this time, it becomes visible again for other consumers to process. It's very important, guys, that a consumer does not process the same message repeatedly. Even most in the case of a standard queue, because their message duplication may also happen, right? And also you do not want your consumer to be overloaded by just by constantly polling the messages and just processing them, right? So, and also there is another case that if there are multiple consumers, you don't want multiple consumers to be working on the same message, right? Because if there is a queue over here, I don't know, this looks like a queue, and there is C1, C2, C3, and there is a single message in the queue. There might be a case that this C1 will poll for the same message, C2 will poll for the same message, and C3, consumer 3, will also poll for the same message. And there the efficiency reduces, and also your same message is being processed multiple times, which you don't want. So what does this visibility timeout does is that if C1 is polling for this message and is processing this message, it becomes hidden for C2 and C3, right? If for some reason C1 is not able to process within that timeout period, like the visibility timeout period, it will become available for other consumers for polling again. It is just there so that multiple consumers cannot process the same message, and yeah, that's how it works. Now there's a simple diagram over here if you want to have a look at it. So let's talk about this thing. There is consumer A and there is consumer B, and then we have this Amazon SQS queue. If consumer A says give me a message queue, right, and then SQS says okay, you know what, you can have the message, and 30 seconds, you have 30 seconds to process the message and then delete the message. Now the 30 seconds is the default time, which is by default provided for the visibility timeout. You can obviously increase it. As you saw while creating the queue, we saw that the visibility timeout was set to 30 seconds by default, but you can increase it. And then after the consumer is done processing the message, I'm done with processing, please delete the message. Then the SQS will delete the message. Now while consumer A is processing the message right from the queue, now consumer B says give me a message, and SQS says no, the same message is being processed by someone else. That's how visibility timeout works. It's very, very important that you understand the difference between visibility timeout and message retention period. Why? Because in the exam they will try to confuse you and trick you by using these terms interchangeably. Message retention period is the maximum amount of time for which you can retain the message in the queue. Visibility timeout is used to hide the message from other consumers if a single consumer is processing the message. I hope that is making sense, guys, right? Alright, so let's move on to the next topic, which says Amazon Cloudwatch. Can we integrate Amazon Cloudwatch with SQS? Yes, it is possible to do that. Actually, Amazon Cloudwatch collects and stores metrics related to Amazon SQS, such as the number of messages in the queue, the number of messages sent and received in the queue, and the number of messages deleted in the queue. Now, you would ask, why do we need all this data? Is this really important, and can it help somewhere, right? It's actually very, very important, and one very big use case of this is auto scaling based on the number of messages in the queue. Now if you remember a few moments back, I gave you an example where there might be a case that the consumers may get overloaded, right? There will be a lot of messages in the queue, in the SQS queue, but still due to the lack of consumers, which are microservices, right, which are just EC2 instances, you can just say, or a Docker container, right, whatever. So due to that, your efficiency is reduced because they are not able to process the messages and something like that. So you need to auto scale in that particular scenario. But how will you auto scale? How will you know that the load on the consumers are high? You may argue with me saying that, we will track the CPU utilization or number of, messages processed in a consumer. Now that will be specific to a single consumer. That will not be specific to your whole architecture that you have done. So for that, there's a very simple thing that you can do. You have your auto scaling group. It can be EC2 instance or Docker, something like that. You have your auto scaling group, because auto scaling is possible in EC2 and Docker everywhere, right? Whatever you want, you can do auto scaling. There are two actions that you can do using auto scaling. One is scale up. You scale up, for example, you increase the number of instances, or you scale down, decrease the number of instances. But on what action do you want to increase and decrease the instances? You will do that by using an Cloudwatch alarm. To understand what a Cloudwatch alarm is, you can watch my Cloudwatch lecture, guys. And this Cloudwatch will be tracking the metrics of your SQS queue. Now this Amazon Cloudwatch will keep a track of your SQS queue, which will contain what? The number of messages in the queue, right? The number of messages in the queue. It will keep track of that. Based on the number of messages, for example, there are 5 lakh messages in the queue and your consumer are not able to handle it. So you have set a threshold, and based on the threshold you will trigger the alarm. You have set the threshold that if the number of messages goes beyond 3 lakhs, then please do the scale up action. Now the alarm, the Cloudwatch alarm, will trigger that auto scaling action to scale up. Now you have set a lower level threshold. For example, if the number of messages is less than is less than 3 lakhs, you will do a scale down action. So that alarm, that Cloudwatch alarm, will trigger a scale down action on the auto scaling group. Now in this way you will be able to handle the load on your consumers, which is just your auto scaling group, based on the number of messages in your queue. Now it is a very important question from an exam perspective, because they ask a lot of questions just revolving around this Cloudwatch and all this thing, auto scaling and SQS metrics and everything. So keep in mind, guys, that is how, and a lot of questions you can answer just by looking at it, by saying that okay, we have to track the number of messages in the queue so that the Cloudwatch alarm will trigger, right? I hope that is making sense, guys. Okay, if you have any doubts, please put it in the comment section. I'll be able to answer it, right? Okay. Okay, so this is another example where this architecture, right, this using SQS comes into the picture. For example, you have a user. This is also another architecture diagram which generally comes in the exam. So from an exam perspective, that's why I've included all these questions, scenarios. So for example, you have a user, and a user makes a payment, right? It calls the /payments API, which you have configured in your API gateway, and it will trigger a Lambda function, and it will send the message into the SQS queue. There is another Lambda function known as sales, right, which will process the which will be a consumer for this queue. So this will be the producer. I'm marking it so that you will be able to easily identify the things, and this will be the consumer. Now obviously the producer can have other actions. For example, it will update with the payment details in a Aurora database, but still the payment needs to be processed. It will be gone into the, so this sales Lambda function will poll for the messages in the SQS queue, which is the sales queue. And then what it will do, it will update the sales database. So this is the producer which will send the details like the payment or whatever the order details into the SQS queue. This Lambda function, which is known as sales, will poll from the queue, from this SQS sales queue, and then it will store it in another database, right? So this is one of the architecture diagrams where they will ask you how you will integrate the services with an SQS queue, right? Now let's make things simpler, guys, and let's see similar kind of example. Let us create a Lambda function and let us see how you can process the messages from a queue that we just created right now in our AWS console. Let us see how we can do that, so it will make things a little bit clear and we'll also have a lot of fun, right? So let's move on to this demo. Okay guys, so let us go back to our console, right? We have our queue over here, so let's keep it over here and let's open a separate window to create our Lambda function. So I'm going to say open in a new, no, not a new window, we'll open it in a new tab, yeah, and I'm just gonna go to Lambda so that I can create a Lambda function which will act as a consumer for this SQS queue. Whenever we send a message into the queue, this Lambda function must get invoked and it should receive the message. Okay, so we are going to create a function, and if you want to like have some overview of it, you can just go to this thing like how it works, what are the pricing and the costs. And if you want me to make a video on Lambda, please comment down in the comment section. I might be able to do a video on Lambda. So let's create a function, and what we are going to do, you can write the function from scratch, right, like whatever you need, but in this case I will use a blueprint, right? It's a very good feature of AWS that there are predefined functions for specific use cases which you can directly use, right, without writing a single line of code. You can obviously understand the code later on, but we already have a blueprint. We're going to use that. So you can, if you select from here, you'll be able to see a lot of blueprints. You see there's a create a microservice that interacts with the DDB table, get S3 object, you can integrate with S3 as well. There are some hello world functions, there are AWS functions, Lex, you can connect it with the chatbot of AWS, which is Lex, you can connect with that. Manage orders with Lex, you can create a fully fledged chatbot or a customer support system using this thing. Process Cloudwatch data. What a lot of things are there, but the one thing that we are concerned about is probably the SQS, which is process messages in an SQS queue. So what does it does? An Amazon SQS trigger that logs messages in a queue. That's it. That's what we need. There is also a Lambda function for SNS topic. You can explore it if you want, and also there is some IT automation stuff as well. If you want to send the CloudWatch logs to a Splunk host, you can also do that. Alright, so let's select this SQS one, and it is a Node.js, a JavaScript function, and I'm going to name this function as Lambda _ SQS. And see, here there is one more thing that you need to keep in mind, is the execution role is very, very important for a Lambda function to have. Because by default your Lambda function cannot access other services on AWS. It's pretty simple. It's a common thing for all the services on AWS, right? So if your Lambda function needs to access, for example, a service called as SQS on AWS, then the Lambda function must have an execution role which permits it to access the SQS queue. Let's make this pretty simple, guys. Let's not create the role over here. I'm going to go to IAM directly and create the role. So I'm just going to open it in a new tab, and let's see how you can create a role and assign a role to a particular Lambda function. So here I'm going to go to roles section over here. If you want a detailed thing about roles, users and groups, I have a separate video on IAM. You can also go and watch that. Okay. Alright, so let us create a role over here, and the role trusted entity type, we have to select an AWS service because we want to assign the role to a Lambda function, which is a AWS service, and the use case in this case will be Lambda. We'll click on next over here, and here we are going to access, we are going to select the Lambda SQS something. Okay, AWS Lambda SQS queue execution role. If you expand this, you can see that what are the allow actions that are available in this role is receive message, delete message, create log group, create log stream, and put log events, right? You can do that. So obviously all these things we need, especially we need the receive message, so that as this Lambda function is kind of acts like a consumer to the SQS queue, we need to have the permission to receive the message from the queue. So I'm going to select this policy, and we're going to attach this policy to the role, and we're going to name this role as Lambda SQS exec role, right? Pretty simple name formatting. And yeah, these are the trust policy, these are the permissions we just saw right now, which are associated with the policy, and then we're going to create the role over here. So this is ready, guys. Now what we can do, we can attach this role to our function. So if I go back over here, and we can choose the existing role which we just created right now. We just click on refresh so that we'll get the role perhaps. Yes, we have the role over here, and this is the code for the function. It's pretty simple code, guys. We just console.log loading function, and we have a asynchronous function over here, JavaScript function, which says just that the message is received, right? And that's it, successfully processed the message. Okay, that's it. Now this trigger is automatically added. So trigger is nothing but your Lambda function may have multiple triggers, right? It may also be associated with API gateway. I have explained this. I have given this demo, if I remember, in my serverless video. You can go and have a look at that. I have explained Lambda in a bit more detail than this. If you want an individual video on Lambda with all the things covered, you can comment down in the section. But your Lambda function can have multiple triggers which can come from multiple services. Your API gateway can be a trigger, SQS queue can be a trigger, S3 can also be a trigger, and likewise SNS can also be a trigger. A lot of triggers are there. So this is by default selected because we want to create an SQS event consumer, and here we have the SQS queue. We're going to select the queue. Currently it doesn't show me the queue. So what we're going to do is we're going to go over to this example queue that we had created, and we're going to select the ARN of the queue, and let's go back and let's paste this ARN over here. So let's keep all these defaults and let's create the function. So if you see now this diagram of the Lambda function, it doesn't have any layers as of now. Layers is a different concept in Lambda. We can just ignore that for now. And we have a trigger over here which is kind of a source trigger. So if we send any message into the SQS queue, the Lambda function should get invoked, right? You can also add a destination, so you can take the message and send it somewhere else, for example a database or something. You can add a destination as well, like a SNS topic. You can publish it to an SNS topic or SQS queue or another Lambda function, or an event bridge bus which may further be connected to any other service. So let's not make this complicated. Let's keep it as the source trigger as of now. And this is the source code. You can test this code, guys. You can create an event, for example, a test event. And let's click on save. And if I select this test event, and if I click on test, it says that successfully processed one message. That's the response. Cool. And one thing that you will keep in mind is this monitor tab, which we will use to check if the function has been invoked or not. So currently, if you see, there is no invocations as of now because this function has not been invoked. So there is no data about the invocation of the method or the function. So now what we will do, it is connected to the SQS. Now everything should work fine, right? If I go to the SQS queue and publish a message, this function, this Lambda function should get invoked, and we should see some response in the monitoring tab, some data over there. Let's go over here and let's try it. So we have this queue. Let's click on send and receive message, and let's say Lambda function invocation, right? That makes sense. Let's click on send the message. Message has been sent and is ready to be received. Let's check, fingers crossed, guys. Let's check if it is working or not. I'm going to go into the configuration, go into the monitor tab, and if you go over here, see, you can see there is one invocation right now. And so if you see, this is the log. It was done like this. And if you go over here, because now we send the message and this was invoked right there. And yeah, that's how it is. Let's double check, and let's be sure that this function is only getting invoked only when we send a message. So we're going to go back over here, and we're going to just say 2, and we're going to send the message. Now this should trigger or invoke the function again, right? Now if I go back over here and let us refresh this monitoring section of this Lambda function, and if I come back down, you see there is only one invocation as of now. Let's try this again. Okay, there is still one invocation. Why is that? Let's go over here and let's try something else, and we're going to send the message. Okay, let's try this again, guys. Okay, as you can see, now if you see, this is the thing, it got invoked again. If you see, it got invoked again. Likewise, if you see, this function is getting invoked, so it is consuming the message which we are actually publishing into the queue, sending into the queue. So it is polling for the message, and that's how this trigger works, right? I hope that is making sense, guys. And let's move on to a bit more theory, guys. I hope this was fine. If you have any doubts, please put it in the chat section or the comment section. Let's move on to the security things. And while creating the queue, you saw some security or encryption things that we were dealing with. So talking about security, guys, SQS integrates with AWS Identity and Access Management IAM for fine-grained access control, allowing administrator to manage permissions for queue access, right? If you see, you remember I just talked about, while creating the queue, I talked about that SQS out of the box provides you with SSE SQS encryption, and if you have a customer managed key, CMK or something in KMS you can also use that for encryption. And as for IAM, I also show you the access policy document of SQS, where you can manage who can access your queue, right? I hope that is making sense. That's about security, guys. Let's move on to the next topic. Let's talk about all of these things that is pending, guys. First thing is long polling. So see, there is two types of polling in SQS. First of all, you know that SQS only supports polling of the messages, not pushing of the messages, right? So there is two type of polling, guys. One is long polling and another one is short polling. Now what is long polling? SQS supports long polling, allowing consumers to wait for the messages to arrive in the queue for a specified period. Long polling reduces the number of empty responses, leading to cost savings and reduced latency. So what does it say? It will wait for the messages to arrive in the queue. Now the thing is, the queue might be empty and your consumer is still polling for messages, which is inefficient. That is, we don't want that, right? So that you will enable long polling. So you poll the message, receive message with long polling, and this is the application which is a consumer or which is processing your messages. So whenever in the question in the exam, whenever there is some question related to efficient management of messages in the queue with time saving constraints, guys, you will always use long polling. Okay, all right. Now let's talk about dead letter queues or DL queues. DL queues are queues used to store messages that cannot be processed successfully after a certain number of retries. They help in troubleshooting and handling erroneous messages without losing them. It's pretty simple, guys. So if there is some message which was not processed by the consumer after a number of tries, right? There was some issue, right? So you can keep them as a kind of a log later on to debug and log purposes. So you can check your dead letter queue and you can see why this message failed multiple times, guys. Okay. Now message deduplication. FIFO queues provide exactly once message processing by automatically eliminating duplicate messages based on the message deduplication ID. We just learned about this FIFO queue that it will first of all sequence your messages. Second of all, it will not allow duplicate messages. So if you want message deduplication, then you have to go with FIFO queues instead of standard queues. And we just saw like a demo and also with a lot of diagrams and examples. You can enable integrate with AWS Lambda. SQS can trigger AWS Lambda functions to process messages from the queue. This enables building serverless applications that react to incoming messages asynchronously. Right, guys? Yep. So that is all about SQS that you need to know for the exam, and also if you want to implement something in real life also, you can use all of these concepts to implement them. Let's move on to SNS, guys. Okay, guys, let us talk about this SNS, right? And you would be thinking, right, what is the use of SNS when we can send messages through SQS, right? If you remember one thing when I was talking about SNS a lot is that it's a polling thing. It cannot push the messages into something, right? Whatever consumer you have to SQS, it will poll the messages from SQS and then it receives the message and then it can process the message. But in some scenarios, you also need the push messages or the pub sub model, which is the publisher and subscriber model. It is also a common design pattern also. A lot of interviews they ask this question. So what is push messages? A simple example will be receiving a push notification on your mobile phone. So what happens in SNS is that you have a publisher, right, which will push the message into an SNS topic, and these guys will be the observers of the SNS topic. Now whenever there is a new message into the SNS topic, it will push the messages to the subscribers or the observers. Now these will be subscribers actually in the term of AWS, but you can also call them observers in a general scenario. So these subscribers are subscribed to this SNS topic where the message is pushed, and then they will receive the messages. Now, a very interesting part of this thing is that your subscribers can be anything. It can be a Lambda function, it can be an SQS queue, it can be a HTTP endpoint, it can be an email, or it can be a SMS, right? I hope that is making sense. So just for the sake of definition, SNS is a fully managed pub/sub messaging service that allows you to send messages or notifications to a large number of subscribers or endpoints. It's a fully managed service. It is completely controlled by AWS. You don't have to worry about setting up anything, any servers or anything, any messaging servers. You don't have to worry about all that. You just have to, just say that, okay, I want to send a message to a couple of subscribers. I just need to create a topic, and that's it. Boom, you can do it. It's a pub/sub messaging that we just discussed. SNS follows a publish subscribe message pattern or a paradigm. Publishers send the messages to topics, and subscribers receive messages from the topics they are interested in, basically which they have subscribed to. Now, what is a topic? A topic is an access point for allowing recipients to dynamically subscribe for identical copies of the same notification. Each topic can have multiple subscribers, like we just saw in this diagram, right? Now this topic has a lot of subscribers. And subscription, subscribers can subscribe to topics to receive notifications, and it supports a lot of subscribers. We just discussed HTTP, email, SMS, SQS, Lambda, and all these things. Then we have push notifications. SNS allows you to send push notifications to mobile devices, Android, iOS, Kindle Fire, as well as other distributed services as well. Talking about encryption and security, guys, SNS supports encryption of messages in the transit using HTTPS and at rest using AWS KMS. It also provides access control through IAM policies. Just like SQS, you can encrypt your messages using KMS in SNS also, and also you can also control who can access your SNS queue by using a simple this thing, IAM policy. Right, I hope that is making sense, guys. Okay, now let us see a very simple what we call a demo or a practical session on SNS, how you can use SNS and how you can create a topic and how you can create a subscriber, and in the end send a message or push a message to the subscriber. So let us search for SNS over here. Now you can click on create a topic. Now here in SNS also you can have a FIFO topic or a standard topic. Same difference only. If you see in FIFO, it's strictly preserved message ordering. Whatever message you push, it will be received by the subscribers in the same order. But if you don't have to worry about that, you can stick with the standard topic, right? I'm just going to name this as an example topic, example underscore topic, and other things, let's keep it simple, and let's not worry about all these things, right? And let's click on create the topic. Now in the subscription section, as you can see, whatever we discussed right now, right, are all in these tabs. The access policy, if you want to control the access policy, you can modify this document. You have the DPP policies, delivery policies, logging, encryption, tags, whatever you need is there over here. You can refer to this section. If you go to subscription, guys, you can create a subscription, and if you see the protocol, you can see multiple things are there which can be your subscribers, like a Lambda, SQS. You can create another SQS queue which will act as a subscriber to this topic, and whenever you push a message from here, the SQS queue will be populated with a message. And then there can be another Lambda function which will be polling the SQS queue. Now this is something known as a fan out pattern, which we're going to discuss in a minute. So just wait for it some time. It can also be a Kinesis data fire host. It can be email, HTTP endpoint, or an application, or SMS. So pretty simple is we'll keep it simple and let's stick with email. And I'm going to create a temporary email. You can use this link to create a temporary email. It will create a disposable email which you can dispose of after your usage, right? So we're going to copy. There will be one something. Okay, we're going to copy this guy. We're going to go over here and put it as an endpoint over here, and we have to confirm it obviously, and then we can create the subscription. So now it's pending confirmation. If you see over here, there will be one notification. Where is it? I think this one. So this one only, I think. Okay, let's click on confirm my subscription. I'll open it in a new tab, just that our email is not lost. We'll go back to a list. Okay, we are here and our subscription is confirmed. And if I go back, this is fine, protocol is email. And if I go to topics right now and let's select this topic, go inside the topic and let's publish a message and see that this subscriber gets the message or not, this subscriber that we just created. So we're going to click on publish message, and I'm going to keep the subject as a test message from SNS. And time to live is basically the settings applies only to mobile application endpoints. So the number of seconds that the push notification service has to deliver the message to the endpoint. It's pretty simple, guys. Message structure, it's pretty simple. Let's make it I am a test message from SNS, something like that. We're not going to keep any attributes, and we're just going to simply publish the message, and it was successful, it says. If I go back to my temporary email, okay, so you can see that this message is now received from SNS. So if I click on here, I will be able to see the message. Probably says I am a test message from SNS. So you see it's pretty simple to do it. Okay guys, so that's it about the demo. You can play around with this topic and you can add more subscription like an SQS queue. You can just mix all of the demos that we did today, like the Lambda one, SQS one and this SNS one, and you can create a full flow of a fan out pattern system. You can take it as a homework and you can do it on your own. If you have any doubts, please feel free to push it in the comments. Let's move on to the next topic, guys. Let's talk about this fan out pattern, guys, and I just gave you an example about this fan out pattern where you can connect your SNS topic to an SQS queue or multiple queues. So basically what you see over here, these guys over here, the SQS queues are the subscribers to your SNS topic, right? And there will be a publisher obviously. And in turn, these SQS queues can be linked to consumers. In this case, these are EC2 instances. Now, what is the advantage of using such kind of mechanism, guys, is that there can be a one source, right, from where one message is there, right, and that is like a source point for multiple consumers which do not want to poll from a same kind of SQS queue. Now in this SQS queue, if you see, you can have a FIFO queue or a standard queue, and whenever this SQS queue, a new message is published into an SQS queue, then only the consumers will start polling for it, right? It's a very good mechanism. It increases the efficiency and it further decouples your application, which gives you a higher flexibility, which is one of the most common types of questions that is being asked in the exams, guys. So keep in mind the fan out pattern where you can use SNS and SQS as a whole along with your consumers and your publishers. Okay, I hope that is making sense. Now talking about CloudWatch integration, guys. Similar to what we saw in SQS, you can integrate your SNS service with Cloudwatch, and it will provide metrics and monitoring capabilities for topics and subscriptions. For example, here is a pretty basic example. You have your application servers, which is your EC2 instances, and it sends your application logs to Amazon Cloudwatch, and your SNS monitors for errors, and then it sends notifications to the operations team or your ops team, right? Automatic, there is no manual interventions. For example, there is one error in your server, SNS will catch it, right? Cloudwatch will monitor for those errors and push a message to SNS, which will be received by the subscribers, which might be emails of the ops team, or I don't know, direct message communication, or some apps, right? Because your consumers, in this case the subscribers can be anything. It can be message, it can be email, it can be a separate application or a HTTP endpoint. We do not care about that. So this is one of the scenarios or use cases that you can keep in mind, like how this Cloudwatch combines with SNS and SQS to provide a lot of different capabilities for your particular application scenario. So the last thing that I want to talk about in SNS is message filtering, guys. Now, if you see what is the standard form of an SNS topic, you have a topic, right, and there is a publisher. It pushes the message or publishes the message, and it is received by the subscribers. Now this can be mobile, this is app, and this is, for example, Lambda. Now if you see this diagram also, now currently if you see this scenario, irrespective of what kind of message is pushed, all the messages are going to the subscribers, right? Even if one subscriber doesn't want the message, that subscriber still receives that message, which is an unwanted thing that we don't want. The message should only be received by the designated subscriber. So there must be some kind of filtering that can be used in SNS, right? And that particular thing is known as subscription filtering or message filtering. So we have event generator or your publishers. There is a topic. There is SNS queue subscription. We send it to queues over here, and based on the particular filtering, it will be sent to the orders queue or the EU queue. You have to use the message filtering option, right? I hope that is making sense, guys. This is also one of some questions I had seen in the exam, so I thought let's include it in the topic. So yeah, guys, that was all about SNS and SQS, and I'm going to continue this integration topic with KMS and Kinesis and Kinesis Firehose and all these things. So let's continue that, and yeah, let's see in the next video. Till then, have a nice day, take care, and bye bye.